Here is the prototype bullseye. Okay, and so currently you can find it at jimmorey.com bull/simplebull.html. And so this code is 800 lines of JavaScript, jQuery, and D3. And so what you'll notice here is the D3 is the dynamic aspect, and it allows for some nice hover things and identification of the numbers, etc. But perhaps after you see it function, it'll be a little bit more useful to spot the JavaScript and jQuery D3 stuff. Anyway, so the game is called Bullseye, and the idea is that the bullseye is a node surrounded by nodes with some property. For instance, in this case, it's the property of being a multiple of 2. And so you'll spot these different. This is the only case where the node is surrounded by even numbers. Okay, so let's give it a shot. If we hit go, it automatically creates a different level, and so this one you have to look for multiples of 10. And so there's a multiple of 10, and so if we click here, here is the node that is surrounded by multiples of 10. Okay, and so we can go through a couple of different examples. And so once again, multiples of 10, and we get better at it. And so each time we do it, we record how much time it takes, and there's means and an accounting system. Now this is just a prototype for now, but what we can see that 10s and 2s are pretty easy, and so that's the easy level here. We can see that it's either going to be a 10, a 2, a 5, or an 11. So let's see if we can get an 11. No such luck. How about a come on, there's the 11. And so yeah, basic easy things to spot. And so there we have it again, the multiples here. And so instead of doing those, you can make it slightly more difficult by having normal. And so in this case, we get to choose from this list, and multiples of 3, of course, is a little bit more tricky because you have to sort of either recognize these things or do a little bit of addition. And so in this case, we can spot it here because we add up the digits and we realize that the sum of the digits is in fact multiple of 3. And so these are a little bit more difficult to master, and so it does take a little bit more time to calculate these things. And of course, because you don't want too many mistakes, you want to be able to track it. And so the key is to look at the node and then run around them. And so finding the pattern is a little bit tricky. Now, in this case, you must have four things surrounding it. So that automatically excludes all of these on the edge as being the bullseye. And so we only have 9 possible choices to look at here. So we can get better at it, and so we can maybe move on to hard. And so hard is just the same thing, but now we include 7. And so 7 makes things much more difficult. And so 18, multiple of 9 plus multiple of 2, so even. So 15, not so bad. Right here, in fact. And so you can see, this is the real tough one, the multiples of 7. And so in this case, you really should know your multiples of 7 fairly well. And so because of the limited choice here, it's not a hard thing here. Now, when we go to expert, it turns out that all of those numbers are possible, but now we're looking for now in numbers under 200, and so this becomes a little bit more difficult. And in fact, probably the multiples of 11 suddenly become a little bit more tricky as well. And so in this case, can I do it quickly? Yes. Okay, so that's the basic bullseye. Now the problem is, of course, you can get pretty bored of this pretty quick. And so, oops, I was onto this and I didn't click on it. Anyway, so there we have all of this sort of covered. But the more interesting thing is when we can change to the network difficulty. And so in this case, we can allow for slightly bigger things going on. And so now it's a little bit more tricky. You have more things to look for. And I should, since I'm looking at a different aspect, I have to take off the content because this becomes a little bit taxing to find these multiples. Where is it? Da, 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 da. Huh. I should be able to find this pretty quickly, but if you give up, you just hit quit, and there it was in the corner. Anyway, so let's pull it back to easy so that we can explore the different geometries. Now, in this case, of course, the scanning for finding it is not so bad. But what we can do is we can change to a different geometry. And so here, the X pattern, rather than this cross, you can see this X pattern actually has 3 different orientations, which makes finding the multiple a little bit tricky. And now that I've gone back to easy, this becomes a lot less taxing. And so we can find these things differently. And so there's an X with this orientation. There's a same orientation, different orientation. Now it's focused in this way. And so actually I'm also highlighting the feature that you can quickly go through and find a few examples by not having wins, I guess having more losses, but I mean, anyway, so the X pattern is quite an interesting geometry. In a similar way, what we can look at is this K pattern. And so essentially here we're looking at 3 different Ks, and this makes it a little bit more interesting. And so this is what I'm calling the curiosity magnet. What's going to bring people back to playing the game after they've essentially mastered the skills with the math. And so in this case, let me see if I can find it. Here it is. Okay, and so the K pattern is quite interesting because of this this less symmetric pattern. And so my favorite, in fact, is this one here, the peace symbol. And so the reason why I find this more interesting is that if you follow this little hexagon around, you will see different orientations of the peace symbol. And so there are 6 different ones, which makes it a little bit more challenging. And so to solve this, you sort of have these ones in the nook here of these hexagons, and then you have walking around these here. And so by walking around, you can sort of find these things fairly quickly, especially with easy. But anyway, this is probably my favorite geometry, and the thing is, you can continue on with a few more patterns. Probably this is the kind of most densely packed one, even though it's sort of a kind of, well, Sierpinski's triangle. What you'll notice here is that with the other patterns, or if you look at the border on the edge, they can't possibly be a bullseye, which makes the searching a lot easier. Whereas this pattern, there is only these 3 in the corners that aren't possible to be a bullseye. And so that means every other node is a possible bullseye, which makes it quite tricky to find, which maybe makes it the search algorithm quite a bit more complicated. Anyway, so but yeah, so there's all the geometries, and the way it works, at least for this set here, is that I generate these patterns using a finite state machine. So once I tell it how to make them, it's not hard to simply say grow some more. And so in this case, you can see how the pattern just gets bigger and bigger. And so technically it could grow to even bigger. Now, there's a bit of a trade-off because you don't want to make this a too laborious a task, and so in some sense perhaps the medium is the the best kind of thing, at least for promoting certain types of rewards. I think if it gets too big, then you get bogged down um, with just brute force. Anyway, so but yeah, so there is a finite state machine that generates each one of these, and the priority queue allows it to form a nice looking pattern rather than, as you can see currently with our K. Well, let's go to piece 2. The piece 2, when it generates, the pattern is a little bit less pleasant, especially when you look at, say, levels like this one here. You know, kind of extra doodads that I haven't optimized the priority queue to make it look nice, unlike the piece 1. But anyway, but yeah, the main thing about the network difficulty is, yes, size is important. Yes, the content difficulty is important. But probably the geometry is what's the actual pull. And this brings me to the sort of the final part, which is what to do next. And so, of course, the geometries allow for some interesting 3D analogs to the same thing, which I've already explored a bunch. But probably for the STEM gamification stuff, what we want to look at is this kind of thing. Let me just, and so that is replacing the content with words. And so in this case, what you'll see here is, I guess, the nodes here are now related to, in this case, what is it? A vocabulary list relating to farms. And so if we have this one now, this one's computer related. And so you can just sort of search around and see it. And so as well, you'll notice the orientation is different so that it really does look like a peace symbol. But anyway, there you can see there's lots of potential here. The orientation, of course, is because of these aren't circular anymore. They are more elongated. And so anyway, so I hope you enjoyed looking at the prototype. It is live, so make sure you go check it out and play with it. And yeah, stay tuned. Hopefully we'll have some more some future work for the bullseye game. Cheers.